In this video, we're going to look at simplifying rational expressions. So the 3 steps to simplifying them is factor first, both the numerator and the denominator, cancel out any common factors that there may be, and then find your restrictions on your domain, which would be any place where your denominator would end up equaling 0. So let's look at some examples. In this first one, you'll see that we don't have anything that we can factor, so we need to go ahead and start canceling out the numerators and denominators that would equal 1. So with 16 and 24, I know they're both divisible by 8, and so my 16 divided by 8 is 2, 24 divided by 8 is 3. And then remember, with our exponents, when we divide, we have to subtract them. And so we would end up with 2 minus 5, which is a negative 3, which is going to put the x cubed in the denominator. So we would have 2 over x to the third. And we need to identify restrictions. So if you go back to your original problem, x to the fifth is in the denominator, so x cannot equal 0. The next one, here we do have to factor. And so in the numerator, I can factor out an x, and I'm left with x plus 7 inside my parentheses. And in the denominator, I can factor out a 4x, and I am left with x plus 7 in the denominator. Notice I have that in both, so we can cancel those. I also have an x in the numerator and the denominator. I can cancel those. And so that's going to leave me with a final answer of 1/4. And then my restrictions would be, it's easier usually to look at your factored form, but x cannot equal 0 or a negative 7, because with both of those, we would get 0 in the denominator and our graph would be undefined. Okay. The next one, we're going to factor this one as well. So this is going to give me, let's see, they have to subtract to get 10. So we're going to use x minus 12 and x plus 2, and then a quick check, x squared minus 12 plus 2 is a minus 10x, and then a minus 24. And then the denominator, we just have x plus 2. We can cancel the x plus 2's, and we're left with x minus 12 is my simplified answer. And again, going back up to the original problem, x cannot equal negative 2. Okay, on the next problem, this is a difference of squares, and so this is going to give us x plus 6 and x minus 6. Okay, and when I look at this denominator, I need to factor that out. And I'm guessing that x plus 6 or x minus 6 is probably going to be one of these. Even if it isn't, I'm definitely going to want to check that, just because that would make my life easier if something will cancel. And so if I have to have 2 factors that equal 24, if I plug a 6 in, I have to have a 4 here, and then I need to check and make sure that my b term is correct. So here I would have 30x, inside I would have 4x, and if I subtracted those, I would get a 26, and I want it to be a negative 26, so I want my outside term to be the negative. Now I can cancel my x minus 6 terms, and I'm left with x plus 6 over 5x plus 4. Okay, and again, x cannot equal a negative 4/5 or a positive 6. All right, in this one, again, we have the difference of squares. So we're going to say 1 plus 3x and 1 minus 3x to factor. The denominator, I can factor out a 4, and I end up with 3x minus 1. Now be careful here, because these two look a lot alike, but they are in reverse order, and that negative makes a difference. Remember, addition is commutative, so 1 plus 3x is equivalent to 3x plus 1. When we put the subtraction in there, they're not the same anymore. So if we cancel these out, okay, we can, but remember we have to factor out a negative first. And so if you pull a negative out of either one of these, you would end up with negative 1 plus 3x, which is the same as 3x minus 1. Okay, so we're going to have a negative 1 plus 3x over 4. And then my limitations would be from up here. So x cannot equal 1/3. Good. And then the last one, we'll factor out a 4x. And that'll leave me with x minus 9. In the denominator, we're going to factor out a 2x squared. And that will leave me with x squared minus 12x plus 27. And we're going to have to factor again. So the numerator is going to stay, and the denominator, we're going to be able to factor this term here. So we need to add our terms together to get negative 12. So we're going to have x minus 9 and x minus 3. Okay, now notice that x minus 9 is in the numerator and denominator. Those cancel. They divide to equal 1, which is what we mean when we say that. 4 over 2, we can divide both of those by 2. And then the x will cancel out the x squared. So 1 minus 2 is going to leave an x in the denominator. So let's see what we have left. We have 2 up here, and that's all we have in the numerator. In the denominator, we have this x, and we have an x minus 3. And then just remember that x, go back to your original, x cannot equal 0, 3, or 9. Okay, and when you go back to the original, that is this guy factored. So I can find my parts here, okay, and confirm. Okay, go ahead and try to check your understanding, and I will post the answer link at the bottom.